Okay, here we go with number 6. Number 6 is going to be slightly different from our previous 5 in that we've got to do an additional sort of pre-step when we set up, because unlike numbers 1 through 5, this one is not shot straight east or horizontally or only in the X direction. So we're looking at number 6. We have a golfer teeing off on a 170-meter long par 3 hole. The ball leaves with a velocity of 40 meters per second at 50 degrees to the horizontal. Assuming she hits the ball on a direct path to the hole, we want to know how far from the hole the ball will land without rolling or bouncing. So I'm still going to start by making my variable lists, but this time I have to include something else. It tells me that my velocity, initially, my total VI in both the X and Y direction is 40 meters per second at 50 degrees from horizontal. So what that means sort of pictorially is that my ball is shot at 40 meters per second at an angle of 50 degrees. So first I'm going to need to figure out my VI in the Y direction and my VI in the X direction. Now I know from my right triangle trig, SOHCAHTOA, that I can use my sine component to figure out the Y and cosine to figure out the X. So to figure out VIY, I'm going to do 40, which is my hypotenuse, times the sine of 50 degrees. And my X component is going to be my hypotenuse times the cosine of 50 degrees. Now, if you're confused as to why this is the hypotenuse times that, make sure to ask Ms. Griffith or Ms. McCaskey about that in tutoring. We've shown it to you before as setting up the ratio where cosine of 50 degrees equals adjacent over hypotenuse. And since what we're solving for is the adjacent, hypotenuse ends up back in the numerator. But if you're confused about either sine or cosine and how to get these two, then please make sure to stop in and ask. So using my calculator and making very, very, very sure that my calculator is in degree mode, not radians, I can figure out what these values are. So 40 times the sine of 50 degrees gives me 30.6 meters per second in the Y direction, and 40 times the cosine of 50 degrees gives me 25.7 meters per second in the X direction. Get rid of this reminder here. So now I can start my lists. I know that A is 0 as usual. I'm back on planet Earth for this problem, so negative 9.8 is my A value for Y. My Vx, remember initial and final are the same because A is 0. So my X value is 25.7 meters per second. My VI, that does matter that it's an initial in the Y direction because I have an acceleration, because I have a force, gravity. All right, but that value is 30.6 meters per second. Let's see what else I know. I know that the hole is 170 meters away. That's going to come into play later, actually. And the last piece I know is delta Y. So we're assuming that the size of the T is negligible. So we're assuming that the ball returns to the same height from which it was launched, which makes delta Y 0 meters. Remember, if it returns, if it takes our full parabolic path back to 0, then the distance in our heights is 0. So using that 0 meters as my delta Y, let's use delta Y equals VIT plus 1/2 AT squared. This time my VI is not 0, so I can't just not write that term down or put an X through it or erase it with my finger. Okay, I have to be very careful there. I'm solving for T, so my delta Y is 0. VI is 30.6 times t plus 1/2 negative 9.8 times t squared. Now, when you get here, you have a couple of options. I'm not going to take the time in the video here to show you how to solve this. You should know how to solve this. You can do one of several things. You can use the quadratic equation. You can use your calculator. If you have a quad solving app, you can graph it. You can do sort of a number of different ways, but if you need help solving a quadratic equation like this, then you need to seek help from either Ms. McCaskey, myself, or your math teacher. But this is something you should be comfortable solving. So when I solve that, my preferred method is to graph it in my graphing calculator and find the zeros. When you do that, you'll get two values. One of the values does not make sense because it's going to be a negative time. The other value that you get is t equals 6.24 seconds. If you did the quadratic equation, you would have gotten one other answer and this. And again, you can throw the other answer out because it just doesn't make physical sense. And ultimately, at the end of the day, physics should at least make sense. So, now that I have my time, I'm going to use my delta x equals vxt to figure out how far the ball traveled. So this is how long the ball was in the air. Let me figure out how far away from where I hit it, or she hit it. It landed. So my Vx, I can't use just any velocity, I have to use my x value for velocity. It's 25.7 meters per second times 6.24 seconds, which is my time. That gives me 160.37 meters. Well, what the question actually asks me is how far from the hole did it land, knowing that the hole is 170 meters from the tee. So to figure out the difference, I'm going to do 170 meters minus where it actually landed to get 9.63 meters from the hole. So my final answer is actually 9.63 meters.